Hi, my name is Peter Wang, and for my final project, I'm going to be doing data visualization for decision matrix of robot. So for context, um, I am currently a part of the VEX robotics program at my high school. Um, our team used the design process to build the robot, just like this one, and then we compete at VEX robotics competition. So the part I want to focus on for this project is the design process. For our team's engineering design process, we have 6 steps: define problem, generate concepts, develop a solution, build and test, evaluate solution, and finally present solution. So the part that best interests me and I think can be best visualized is generate concepts. So for this step, our team first brainstorm about the possible solutions to a problem, and then we compare them and use a decision matrix to decide which solution is the best that can help us solve the problem. So for this project, I want to dive deeper into decision matrix. A decision matrix is something that evaluates a list of options as decision-making tool. It gives points to weighted criteria for different types of options, and then through the points given, we will decide on the most feasible and best solution to a problem. Now I have given the context, let's get on to the procedure for this project. So there are 3 parts to a robot. There is the base, there is the intake, and there is the lift. So these are the 3 main parts to a robot. And the part that I'm going to focus on is the base. So for our generate concept engineering design step, the first step is to brainstorm possible types of bases, since I want to focus on that. So the 5 types of bases that our team came up with are Kiwi Drive, Holonomic X, Holographic H, Square, and Tank. But my question is, which is better? So that is when decision matrix comes into play. So this is going to be my initial data for the data visualization that I will be doing for this project. So first, let's look at this initial data. This is a decision matrix with 8 criteria: speed, efficiency, build ease, weight, compatibility, practicability, driving ease, and mobility. And on the left-hand side, um, these are the 5 types of bases, which are the possible solutions to this problem. And giving points to each type of basis for each criteria, um, we arrive at a total which favors holonomic X being the best fit for this project for this robot. So yeah. However, although holonomic X is the winning champion, there are 2 problems that that really bothers me. So the first one is it is very hard to understand just by glancing at the table. So just by looking at this matrix, it is very hard to understand what I'm trying to achieve and what the results that I'm trying to present. So that is one problem that I want to solve with data visualization. And the second problem is, what is the relating percentage amongst the options and criteria? So in this project, I'm going to use Python and Matplotlib to visualize this decision matrix in order to answer the questions that I have. So let's look at my program. So I have entered in the initial data. I have the 5 types of bases here and 8 criteria that matches the 5 types of bases. So this is my initial data. And over here, I'm just creating a very simple bar graph. This is the first graph that I will create for this project. So as you can see, these are the 8 criterias, and I have matched them with the 5 types of bases. And on the right, this is the result. The 5 types of bases with each of their scores stacked on top of each other for the 8 criterias. And as shown, it is very easy to see that holonomic X is the winning champion. Unlike the decision matrix table that you saw in the slides, this one is actually very easy to understand just by looking at it, because holonomic X has a bar that is the highest, which indicates that it is the best solution to a problem. So after I have achieved this graph, I want to find the winning base type with Python programming. So I came up with a couple new lists, and I ran a for loop that appends each score of the 8 criteria for each type of basis. So basically, this iteration ran through 5 times for all the 8 criteria, and so this is the result. Kiwi total is 13, holonomic X is 50, holographic H is 20, square is 17, tank is 32, and our result is the best score and type is holonomic X, which scored 50. So I just wanted this part because this sets up the data that I need for the next graph, which is this one. So since this data is already in the Python program, I can move straight on to this pie graph. So for this pie graph, as you can see, the percentage of each type of base is listed in comparison to another. So I wanted this because this pie chart allows the reader to easily understand how much better a base is than another. So for example, Kiwi is at 9.8% and holonomic X is at 37.9% in comparison to the total score of all the bases. So since Kiwi is at 9 and holonomic X is at 37, it is very reasonable to conclude by just glancing at this graph that holonomic X might be 3 times better than Kiwi drive. So this is something that I wanted to achieve with this graph, which is to easily help our team and readers to understand what is going on and to generate the relationships between the different types of bases. So over here, these are the parameters set for this pie chart. I ran for loop to get this the sets, then set the ratios for each type of basis based upon their score and the total score, and then set the colors for each of them. So this is basically what this pie chart parameter section is about. And then further, as you can see, I have dived deeper into evaluating the relationships amongst the criteria for the winning type of base. So over here, the percentage of criteria is listed in a bar chart for this winning base type holonomic X. So as you can see on the left, I have set the bar chart parameter for the criteria. I ran through a for loop, and using the axis, I graphed this bar graph over here. And this final section of code is just to draw the lines, this top line and bottom line, to better help to visualize the percentage of criteria with the winning type of base. So yeah, so this is what I did for my final project, which is to visualize the decision matrix and to visualize the relationships between the different types of bases and the relationship amongst the criteria of the winning base. So just to look at it more clearly, the final result is as shown. So what resulted from this project is that it is very easy to see that holonomic X is the winning base amongst all the types of bases, and that we can easily see the relationships amongst the different types of bases and amongst the criteria for the winning base. So yeah, this is what I did for my final project, and thank you.